Good morning, friends. Today we are going to discuss about deadlock in operating system. This is important concept and important technology. How the process releases from deadlock. We can see that one by one. See, let's go to discuss what is deadlock. This is a situation how that process cannot able to work furtherly. See, this is the set of processes are blocked because each process is holding a resource and waiting for another resource. That's why. See, for example, there is a traffic signal in a road, and there is a to train track crossing, there is a possibility in that situation. There is a possibility to make deadlock. See, the example for this deadlock is the train traveling on different track. Suppose in the particular situation, the two train going to crossing the track, in the sense compulsory there is one train should wait for a minute or wait for some time for another train going to cross the track. Then only that two train becomes safely reach their destination. See, look at that example. Two trains are traveling on a different track. If a crossing came, there is a crossing place came, a train must hold, whether any one of the train must hold or wait for some time to continue the journey. Suppose that two train drivers thought that there is no waiting time for both the trains, essence, definitely that accident becomes happen. That's why the two trains become going to wait for either first train or second train going to wait for some time. Like in chess, there is a checkmate situation, is the deadlock situation where there are no chance to escaping and have to hold or sometime to move. Here the deadlock situation in database, there is no possible to take place in two transactions simultaneously at single time period in the same account, bank account. It holds one transaction in a queue to proceed. There is no possibility. Definitely there is no possibility to make two transactions at the same time period in a bank account or any account process. Then there are four conditions to occur deadlock. We got to discuss that conditions that a process undergone deadlock situation. How we can identify that process is in deadlock situation. That following four conditions, if any one of the conditions comes under that four conditions meet in the process, definitely that process comes under deadlock. The first condition is mutual exclusion, second one is hold and wait, and third one is no preemption, and fourth one is circular wait. Let's look at that one by one. Mutual exclusion. Yes, this mutual exclusion is accessing a shared variable. That is the process. Any one of the process, we have n number of processes in our computer. In that n number of process, there is only one process going to access a shared variable. In that situation, that process is said to be in critical situation. Which means that shared variable is a common variable. Every process, each and every process can have rights to access that shared variable. In that situation, in that position, only one process going to access that shared variable. In the sense, there is a critical situation which is called during that accessing time, another one process, let's assume that another one process or another n number of process can try to access that critical region, which means critical resource. If so, there is a deadlock occurs. One process at a time can use that resource, which means that shared resource. Here, we can assume that a resource is a shared one. At any particular time period, definitely only one process going to access that resource. Then only the deadlock becomes avoided. Then second one, hold and wait. Is Look at the diagram. There is a processor, and then there is a primary and secondary process, and a process holding at least one resource in is waiting to acquire additional resource holding by another process. Yes, if you try to access one resource, that resource can be holded by another resource previously. In this situation, you must hold one resource and wait for another resource. This is called the hold and wait. If you meet this situation, definitely your process going to face deadlock situation. Then next one, no preemption. Here, this no preemption is a resource can be released only voluntarily by the process holding it after that process has completed its task. Definitely, if any one of the process going to occupy or hold the resource, that resource can be released after completing the process, entire process. From that process, it can be released that resource from that resource to that process to another process. Number of resources can be feasibly removed from a process holding it. Yes, each and every process can hold resources. After completing their job, completing the process, it will be released that resource from that situation. Next is circular wait. Yes, you must wait for each and every minute, which means there is a set of process, which means n number of processes is there. P1, that is process 1, P2 process 2, process 3, process 4, process 5, up to n number of processes is waiting for processes, such that process 1 is waiting for a resource, but that resource is holded by process 2. Suppose process 2 is waiting for a resource, that resource is holded by process 3. In that situation, definitely the deadlock becomes occur. That process n is waiting for, if it is continue in the sense that process n is waiting for resource process, that is resource n minus 1. In this situation, definitely that deadlock going to occur. So how we go to handle this situation, how we go to avoid this deadlock, and how we go to smoothly run our process, which means that resource allocation graphic, it is used for identifying whether there is a deadlock or not. We can easily identify if deadlock is there, in the sense that process going to blocked state. After releasing that resource, that deadlock going to occupy that resource and complete that process. That is the, if we look at this example, if graph contains no cycle, in the sense there is no deadlock. If graph contains a cycle, it means a single cycle, in the sense if only one instance per resource type, then deadlock. That means there is a possible to make the situation becomes deadlock, but there is no serious situation. Then if several instance, which means instance in the sense process, if